So our next video, we're going to keep proving and keep having these two column proofs, but now we're not going to have to prove two triangles are congruent. We're going to have something like prove these two angles are congruent or prove these two sides are congruent. And so we're going to have to come back to the Cpctc we've already talked about. So let's review that. That's just corresponding parts of congruent triangles are congruent. So if we can prove that the triangles are congruent, then we can prove that a certain side or a segment or an angle or whatever is congruent on both triangles. So let's look at example 1. We're given that segment AE, and this should be perpendicular on both of these. We're given that segment AE is perpendicular to segment DE, and so they have a right angle already drawn in. We're given that segment EA is perpendicular to segment AB. We have another right angle. And we're given that C is the midpoint of AE. Alright, so we can go ahead and draw our dashes in to show that AC is congruent to CE because C is right in the middle of that segment. But this time, instead of proving the triangles are congruent, we want to prove that segment CD is congruent to segment CB. So what we're going to do first is prove that those triangles are congruent. And so we have an angle and we have a side, so we need some other piece of information. So I see right here we have a vertical angle. Alright, so we have the two congruent angles from vertical angles. So now we have enough information to prove that those two triangles are congruent. So let's go ahead and start our proof. We've got our statements. We've got our reasons. So we'll start with our givens. Segment AE is perpendicular to segment DE. Segment EA is perpendicular to segment AB. And then C is the midpoint, so I'm going to use a little shorthand, but you can write it out. I don't have a lot of room on here. So C is the midpoint, so say MP, of segment AE. So then we need to put in our proof that we have our right angles. So angle A is a right angle, and again I'm just abbreviating to save some space. So angle A is a right angle, and we know that from the definition of perpendicular. We know angle E is a right angle, and that's also the definition of perpendicular. And then we said that AC is congruent to CE. So segment AC is congruent to segment CE, and that is from the definition of midpoint. So that's everything we just talked about with what we got from our givens. Alright, and then I'm just going to continue my two columns on this half. So to make these triangles congruent, we talked about those vertical angles. So we have that angle ACB is congruent to angle ECD. We know that from the vertical angles theorem. So now we have our angle, side, and angle, and we know that these triangles are congruent. So triangle ABC is congruent to triangle EDC, and we know that from angle, side, angle. So everything we've just done is just like we've been doing in class. The only difference now is we have to go a step further, and we have to prove that segment CD is congruent to segment BC. So if we look at where segment CD and CB are, this one and this one. So we want to prove that they're congruent. Well, now that we've already proved that the triangles are congruent, we can use Cpctc to prove that those segments are congruent because those are corresponding segments of these two congruent triangles. So our last step is just saying CD is congruent to CB by Cpctc. And we're done. For our next example, we're given that segments QR, SR, WR, and VR are all congruent. So there's already a dash drawn in on each of those segments denoting that they're all congruent to each other. We want to prove that segment QT is congruent to segment WU. So let's first find those segments. Oop. So here's segment QT, here's segment WU. So those are the segments that our goal is to prove that they're congruent. So we're going to eventually have to work our way down to those triangles so that we can use Cpctc once we prove that these two smaller triangles, RQT and RWU, are congruent. But first, we need to go with what we have. So we're told that those sides are congruent. So if we look at our big triangles, which is QVR and RSW, if we look at those two, we can prove that they're congruent. We already have two sides that are congruent. And then if we look at this angle R in here, we can see that we have vertical angles and they're congruent. So if we start with our table, we have our statements and our reasons. We can start with our given. QR, SR, WR, and VR are all congruent. We know that from the given. And the next thing we said was that angles QRV and SRW are congruent from vertical angle theorem. So now we have two sides and an angle, and that angle is included, so we can say our two big triangles are congruent from side angle side. So we have triangle QRV congruent to triangle SRW by side angle side. So all we did was prove that the big triangles were congruent. But we're not quite done yet. We still have to get to that small segment, and we're not given anything else. So we have to kind of keep working until we get smaller and smaller and can prove that QT is congruent to WU. So now that we have our two big triangles congruent, we can say that angles Q and W are congruent from Cpctc. So if we say that those two are congruent, put a little mark, talking about these two. So we say angle Q is congruent to angle W by Cpctc. So now if we look at our little triangles, that one and that one, right? Angle Q or triangle QTR and WR. Now we have a side in each are congruent, and we have an angle in each are congruent. So we're almost there to where we can prove those two smaller triangles congruent. So we have that side and angle, and if we look at just the segments QR and TU, if we ignore that SV, we see we have another pair of vertical angles. So let me change colors here. Let me put two curves there because we already used one curve. So if I change to a purple, I can say that that angle and that angle is congruent from vertical angles. So if we add that in, we have that angle QRT is congruent to angle WRU. And we know that from the vertical angle theorem. So now we have an angle, a side, and an angle, and that side is included, so we can say that these smaller triangles are congruent by angle, side, angle. So we have triangle QRT congruent to triangle WRU by, angle, side, angle. So now we first proved the big triangles were congruent, then we worked our way into the smaller triangles be congruent, and now we're in the triangles that have the sides QT and WU. And since we proved those two triangles to be congruent, we can say that segment QT is congruent to segment WU by Cpctc. And that's all we got to do. You just kind of got to think big and work your way down to the point and the pieces that you need.